Welcome everyone. So we're going to get hands on the keyboard hacking of our router started very shortly in just a couple lessons. But before we do that, I think it makes the most sense to talk a little bit about IoT penetration testing and the methodology that we'll follow for IoT pen testing and just how that differs a little bit from the regular network penetration testing or maybe web penetration testing that you may be used to. And in doing so, we can chat about how our goals will be the same in some areas and in some areas they'll be different. And this is going to help us a lot when we're doing our recon and penetration testing of the router because we'll know what exactly we're looking for and what goals we have. I think the best place to start is actually to look at the architecture of an IoT system or ecosystem because there's a lot more components that actually make up this IoT ecosystem than just the specific IoT device itself. So with that being said, I'm just going to hop over to the whiteboard and we're going to take a look back at our smart lock and kind of try and design out all of the different pieces of that system that we would need to give it the functionality that we want in a smart lock. Okay, so as I mentioned before, we're going to be looking at this kind of imaginary smart lock that we were looking at in lesson one, and we'll talk about building out some of the features that's going to take it from just being, a regular pin combination lock into being a nice smart lock that's going to have the features that make it attractive as an IoT or smart device. So of course, at its base level, we've got this pin pad, and then of course it's going to connect to the door. And at a very basic level, when you enter the combination, maybe 1, 2, 3, 4, then the door opens. But that doesn't make it a smart device or really make it super useful outside of just being a regular pin combo. So maybe one of the first features that we want to add in is that users can access this through some sort of interface and they can add or manage what pins are available, and they can add users, for example, and give them pins, and maybe they want to do that through some sort of application. So the next thing I'm going to bring into our design is we'll just bring in a phone to represent that. So I just brought in the mobile phone here, and you can do this from your computer. Sometimes people do it from their computer, but I think a lot of people are using their mobile phones for this today. So it's a good representation of how a lot of it functions in the real world. I'm just going to draw this little cloud here around us because we'll say that all of this communication here is my really bad cloud, that this is all happening and this is in the wireless local area network. So we'll say this is the WLAN, and then we can have communication locally as long as we're both on that same wireless network between the two devices. And it's basically just going to be using whatever ports are open on this. So, sometimes you see SSH being used for these apps. Sometimes there's even Telnet. It's kind of the wild, wild west in these IoT devices. Maybe this device has like its own little web server that it hosts for configuration or setup. Very common to see that. So maybe we'll see something on port 80. And we're going to look at this more in depth later, but it's just basically, we have this local area connection of, whatever ports are open we can be using. So what I'm going to do now that we have kind of our first interface here is we can actually start mapping out our attack surface for these devices. So I'm just going to start keeping a list. And as we add more features, we can talk about how those could be exploited. So the very first thing on our attack surface here list, and these are not in any particular order, by the way, I'm just kind of listing them by how we add features, is that local area network. So we'll just call this the internal network. So if we're going to be finding exploits or things like this, then it's going to be where someone already has access to that local area. Usually it's going to be a wireless network. So maybe we don't want to actually have to use the Wi-Fi to unlock this lock, and this is something that's very common with these smart locks. Maybe we just want to open up the phone and we put it close to the lock and then it opens up. So something that's really common with these smart locks and other IoT devices is that we're going to use some other form of what I'm going to just call short range wireless to communicate back and forth. And this could be something like maybe we use Bluetooth. So I'm going to say BT. Maybe we use NFC, for example. Maybe we use, I don't know, RFID. Or maybe even some other type of proprietary protocol. So this is another attack surface for us here. So I'm going to call this short range wireless here. And that gives us another attack vector. So that covers if we are at home basically, or we're close to the lock. Maybe, we had some really nice features here, and some of these smart locks, this is where they'll end. They just have that, NFC communication where we can, set it up through the local area network, and that's all people want. But maybe, for example, I am at work, I'm away from home, and I'm worried that I forgot to lock my door. And I want to check if it's locked, or I want to be able to either lock or unlock it from anywhere. Basically, I'm on 4G or I'm on a different network. I want to be able to lock it. So in order to do that, I'm just going to bring in another phone that we'll say is, outside of the WLAN. It's just in the, wider area network. It's out in basically the internet. As designers now, if we're trying to, figure out this architecture, the one option we have is that we can try and set it up so that, we can come from outside the internet, and we're going to try and, come into this home network, through the modem or whatever this gateway is, and then inside into the network. And, if you've ever tried to do something like this at home, you may know that this can be a pain to set up. There's a lot of security implications to it. And for the average consumer, it's maybe something that's, quite tough to set up. So what we're generally going to do is we're not actually going to, communicate directly, from our app or whatever outside of the local area network in. So what we'll generally do in these ecosystems is we'll bring in some sort of cloud service, and then we're going to initiate some sort of connection, outside of this WLAN. We're going to reach out to that cloud service, and then we're going to have that communication going back and forth here. And generally there's going to be some sort of API endpoint that's communicating here, and also probably at this end here. So for example, if we wanted to maybe, check the status of the lock, then we could just ask over to the API that's running the cloud service, and it would give us the response of the lock back. And we would have that communication here back and forth between the lock and the server. That's kind of like this polling method of communication where it's constantly updating. And then, for example, so if we wanted to say from the app, hey, can you unlock the door, for example, it's going to send that message over into the cloud server. And then when this device polls, it's going to check and see that it should unlock itself, and then it's going to unlock itself. And then we don't actually have to worry about sorting out any of that communication that comes, from this external device directly into the network. So this adds us another 2 pieces of attack surface that we should write down here. So the next one is this mobile app, right? So we should be taking a look. If there's a mobile app for our IoT device, we should be definitely taking a look at that. And then the 4th one is anything external, but I'm just going to put it as API because that's generally what it's going to be. So we should be taking a look at that external API interface. So then there's one other attack surface that we haven't talked about, and which is one thing that's kind of unique to IoT devices, and that's we haven't really talked about the actual hardware for this smart lock itself. So I'm going to use the abbreviation of hardware here, and this is where we have this unique attack surface or avenue that we generally may not have in the traditional web penetration testing or network penetration testing, where we can actually go out and buy this IoT device ourselves, or if we're doing penetration test, it's going to be given to us, and we have access to the underlying hardware where we can then use that as an additional attack surface. So I'm going to add that here as the 5th one, and I'm just going to use the abbreviation of hardware here as HW. So in this course, this is actually what is going to be the main focus of our IoT hacking, is this hardware portion itself, the unique aspect. The reason for that is because, so these other ones, so especially, the internal network assessments, the mobile app assessments, the API, and then if we have a web server that's being hosted, all of those, there's really good resources if you're coming through TCM Academy for specifically, you've got the practical ethical hacking course, which goes over the internal network and some external network. We've got a great mobile app penetration testing course. We've got a good web app penetration testing course. Those are all really covered in detail. And for IoT devices in this IoT infrastructure and architecture, 90% of what's covered in those courses is just going to apply to these. They don't differ too much, with a few caveats that we will cover in this course. So that's why we're going to be focusing mainly on the hardware aspect in this course. Now, the one thing I want to point out about the hardware aspect, or vulnerabilities or exploits that we find with the hardware, is that depending on the device's functionality and what it does, a lot of these hardware, what I would call vulnerabilities or exploits or things like that, generally a lot of times the manufacturers are not going to be as concerned about them. So if we look, for example, at the smart lock, this is a good example and why I've brought it in. If we look back at that kind of made up vulnerability that or exploit that we found where in our penetration test we were able to open it up and then there was an exposed UART connector that an attacker could connect to, and they got the pin printout from that. So that's a great example of a purely hardware hack where the vendor is probably going to be concerned about that because attacker from the outside of the house could then breach the system and unlock it. However, if we look at the router we're going to be looking at, and maybe we just take a very similar example where an attacker could open up the router, connect to the UART, and for whatever reason it outputs the Wi-Fi password. And then the attacker can get on the Wi-Fi. Well, is that really a vulnerability or an exploit? I mean, the attacker then has to enter the person's home. They have to get to the router, and a lot of routers they already have a WPS button on them where you can push them and get access to it. So maybe that's not necessarily considered specifically a vulnerability. So generally what we're looking to do with these hardware hacks is we're actually looking to take either the access or the information or whatever we can find with them to then amplify or make it more efficient to attack these other different avenues, like for example the external API, maybe the mobile app, or even this internal network hacks. So maybe from our hardware analysis, we're able to find, for example, some bash scripts that we can take a look at and reverse engineer, or even some sort of executables that we can reverse engineer. And then this makes it easier for us to find, for example, maybe a command injection or a buffer overflow that we can, abuse either through the API or through the mobile app, or maybe even just on the internal network. And these are the kind of exploits or vulnerabilities that security researchers and even the, if we go to the other side, the black hat hackers are going to be looking for. So if we're doing this as a penetration test, then of course it's our responsibility to, check all of the avenues and report on them. But as security researchers, those are kind of the big things that they're going to be looking for. So just to give an example of some of this actually out in the wild, I wanted to share a recent blog post that I found interesting from the Zero Day Initiative. So if you're not familiar with the Zero Day Initiative, I would definitely recommend checking out their blog and this Who We Are. But one of the things they run is they actually run this Pwn to Own contest that just recently happened where they invite security researchers to come bring pieces of hardware or equipment, and then they actually, if they pwn them, then they get to own them. But now it's changed into actually just getting cash prizes. And this blog here is actually chatting about a very recent discovery in another TP-Link router, so the TP-Link Archer. And there's two teams that found both a local area, so that WLAN or that local area that we're talking about. They also found a WAN, so this wide area network or external entry. And they both won cash prizes for this research, which is super cool. The other thing that I noted about the vulnerability is actually, if you look at the top here, they're observing these exploits already be attempted out in the wild by the Mirai botnet, which is a very famous botnet that is known to target IoT devices. So these exploits that have been found and published, they're already being used out in the wild by this botnet to get into people's internal networks from the external. So not great. The other thing that I wanted to mention too is, so sometimes these security research teams afterwards, they'll write up how they actually found these exploits. If you look through the blogs on here, there's lots of great blogs about how these exploits have been found. And very, very frequently, they're going to start with some sort of hardware hacking or hardware analysis so they can get some sort of internal shell to do debugging and also dump the firmware and then reverse engineer that firmware, because it just really gives you a leg up in your analysis and looking for these vulnerabilities and bugs if you can start with that shell or some sort of connection in the background and then the actual executables that are running in the background to be able to reverse engineer those. So something to keep in mind. That wraps up this lesson, and we'll hop over to the next one. We're going to start taking a look at the recon phase. I'll see you over there.